As a quick review of wave interference before moving on, let's remind ourselves what that is. What we're really talking about here is essentially wave overlap. What is the way that waves are overlapping to change their behavior? And the two types of wave overlap we tend to see are constructive and destructive interference. That's how we label them. So what is constructive interference? That one's a little more complicated because that could be a peak and a peak sort of adding together, and it could also be a trough and a trough, which would also sort of add together because they're in similar directions. So we say that constructive interference is really like an adding or a combining effect. But when we have destructive interference, it has to be a peak and a trough because we have like a subtraction effect where they are sort of taking away from each other. And we saw this with some of the various activities that we did. But this happens in several different ways, and some of those waves have special names. So one of the ways that sound specifically interferes with each other, those waves, is we hear what is called a beat frequency. So if there's just a slight difference, if you see how speaker 1 and speaker 2, their waves are just slightly different, the spacing's just a little bit off, that creates every so often in this regular pattern, our beat frequency, points where they line up together and points where they are opposite of each other, given the place where each wave is at. So our beat frequency is just very simply frequency 1 minus frequency 2, but in the overall, what we get is this rhythmic over and over repetition of the same shape due to those patterns sort of being with each other and against each other regularly. So to talk about our next idea, we have to revisit the standing wave. So what is a standing wave? If I think about a regular wave, I'm just going to do one wavelength, and then that wavelength reflects. It's going to return to where it came from. It's going to flip, and I have this sort of mirror image of the wave I started with. But what I've created is on each end and now in the middle, I have a node, which means at some of these maximum points, I have what we call antinodes. And so those nodes and antinodes are places of maximum constructive and destructive interference. So in the middle, at my nodes, I have maximum destructive interference. And at these antinodes, I have maximum constructive interference because I have the reflected wave and the actual wave interfering with each other differently in these different locations. When we do this at our natural frequency of vibration, those are the words you often see, we call it resonance. That's a resonant frequency. And so there's the fundamental frequency of resonance, and then there's these different harmonics or overtones that we looked at in our speed of sound lab. Typically, those fundamental frequencies are a quarter or a half a wave, but we always go up in sort of half wave increments. So if we're thinking about path length difference, this is just a way to sort of quantify our interference. And so what we're going to look at is, well, how and where do these waves overlap? So if I look from source 1, this red one, 1, 2, 3.5. So point A is 3.5 waves or peaks away from that source, whereas the green one is 1, 2, 3, 4, 5.5. So if I have 5.5 and 3.5, well, you see that those both land on troughs. And so since that's a trough-trough interaction, I have constructive interference. If I count from the other one, 1, 2, 3, 4, 5 waves away from point C for the red source 1, and source 2 is 1, 2, 3.5 waves away from the green source 2, well, I see that that is a different interaction. That is a trough and a crest. And that's destructive interference. So we have constructive and destructive interference, but really what is this about? It's about the path length difference. So this difference is a difference of 2, whereas this difference is 1.5. So when we have an even path length difference, that leads to constructive interference. And when we have an odd path length difference, or like a half point, 1.5, 0.5, we see destructive interference. That's only for the difference, not the total. You see at point A, that's 3.5 and 5.5 waves. Those are both sort of numbers with a 0.5 in them. But when I take the difference, the path length difference, I get 2, which is an even number. And then when I take the opposite of the other one, we see it's a trough and a crest, which will always be true for destructive interference. Constructive interference could happen on a peak and a peak, much like at point B on this diagram.